We're going to find x and y intercepts of rational functions. You always want to start by factoring the numerator and denominator and canceling anything that cancels. This is our reduced equation. This is what we're going to keep coming back to. So before we find the x and y intercepts of this equation, let's look at just a review problem really fast. An x-intercept is where the graph hits the x-axis. And notice this point, if it's 3, 0, the y value is 0 at the x-intercept because we're not moving up or down at all. Our height is 0. And then here at the y-intercept, where we hit the y-axis, the x value is 0 because we're not going left or right at all. So x-intercept is when y is 0, y-intercept is when x is 0. So if we're trying to find the y-intercept, that's when x is 0. And remember, we have to go back to this reduced equation. So that's 1/2. The x-intercept is when y is 0, so 0 equals 1 over x plus 2. And then in your next step of simplifying, it's always going to be multiplying the left and right by the denominator, getting it to cancel. On the right side it cancels because it's in the numerator and denominator, and on the left side 0 times anything is 0. So now we have 0 equals 1. If x equaled 0, 0 would be the x-intercept. If x equaled 1, 1 would be the x-intercept, but 0 equals 1 here. That doesn't make sense. So that means that there's none. There's no x-intercept. Let's look at one more example. If we're finding the y-intercept, remember we're plugging in 0 for x, and we couldn't simplify this any further. It didn't factor or nothing canceled. So this is what we're going to keep coming back to. So that's 3 over -1, which is -3. And then x-intercept, plug in 0 for y, multiply both sides by the denominator, getting it to cancel. 0 times x minus 1 is 0. Subtract 3 from both sides, and x equals -3. A shortcut with the x-intercept, you can always set 0 equal to the numerator right from the start, because in your first step of solving, we multiply by the denominator to both sides and it cancels, so you're always left with 0 equals the numerator. But since there's so many rules in finding the x-intercept and y-intercept and vertical asymptotes and holes and horizontal asymptotes, I just would remember x-intercept, plug in 0 for y, y-intercept, plug in 0 for x.